Question number 6. Let f of x be 6x over x plus theta. Be differentiable for any real number and f derivative at theta is 1. Then find the value of theta. We have the function f of x here. So what we need to do, f derivative at x, the derivative of the numerator 6 times the denominator x plus theta, minus derivative of denominator 1 times 6x over denominator square x plus theta the whole square. Now we simplify this one. 6x minus 6x, 0, 6 times theta. So 6 theta over x plus theta square. Now look, f derivative at theta is 1. So f derivative at theta is equal to 6 theta over theta plus theta the whole square is 1. So implies this is 2 theta square, 4 theta square, multiply both sides. 6 theta is equal to 4 theta square. Implies, let's write this as 4 theta square minus 6 theta is equal to 0. Implies 2 theta, common factor, 2 theta minus 3 is equal to 0. This product to be 0, either theta should be 0 or theta is equal to 3 over 2. Now let's look at the problem again. To be differentiable at any real number, the function should be defined for all real number. So the problem should be modified. A differentiable function, differentiable throughout its domain. That means not for any real number. We need to modify the problem like this, should be corrected like that. So for theta is equal to 0, our domain will be all real number except 0. Therefore, it will not be differentiable at 0. So theta is equal to 0 cannot be the answer. But at theta is equal to 3 over 2, the function is differentiable everywhere in the domain. So our answer will be only 3 over 2. Question number 7. If the function f of x is given by the expression as you see, and it is continuous at 0, at the point where the function is split, then what's the value of alpha? Simply, whenever we have continuity, we know the limits exist. That means here for the function f of x, we know that the limit of f of x as x approach to 0 from the right is equal to limit of f of x as x approach to 0 from the left. This implies the limit of the function as x approach to 0. X approach to 0 means x greater than 0. If x is greater than 0, our function is limit of what's f of x? 1 plus 3x the power of 1 over x as x approach to 0 from the right is equal to limit of what's f of x as x approach to 0 from the left. X approach to 0 from the left means x less than 0. So if x is less than 0, our function f of x is minus alpha minus x squared cos 1 over x. So we have to evaluate these limits as x approach to 0. Use substitution, substitute 3x by u. So this can be expressed as 1 plus u, the power of 1 over x. 3x is u means x is u over 3. So this can be 3 over u. As u approach to, when x goes to 0, 3x goes to 0. From the right, is equal to the limit of this one, minus alpha minus the limit of cos 1 over x over 1 over x squared as x approach to 0 from the left. As x approach 0 from the left, 1 over x gets very large. So cos value oscillate between minus 1 and 1. Cos 1 over x is bounded value. Even if it is oscillate, it is bounded from minus 1 up to 1. And the denominator gets very large. So some bounded values, a value oscillates between an interval, bounded interval, divided by a very large number, it goes to 0. Therefore, this limit goes to 0 and it remains minus alpha. What about this one? 1 plus u to the power of 1 over u as u goes to 0. The limit, that is e cubed, is equal to minus alpha. Therefore, alpha is equal to minus of e cubed. Question number 8. Let y be cosh xy, then dx by dy. Look, here y is equal to cosh xy. So dy by dx, derivate both sides with respect to x. Dy by dx is equal to the derivative of cosh is sinh xy, apply chain rule, times d by dx of xy, the product rule. So the derivative of x is 1, y, plus derivative x times derivative of y, dy by dx. Now distribute sinh xy over this. This can be written as y times multiplication is commutative. Sinh xy plus x times sinh xy dy by dx. Collect like terms. So bring this to the left and take dy by dx common. So this becomes 1 minus x sinh xy dy by dx is equal to what remains here on the right, y sinh xy. Now multiply both sides by dx by dy and divide both sides by this value, y sinh xy. This implies dx by dy is equal to, multiply both sides by the reciprocal, so 1 minus x sine hxy over, divide both sides by this, y sinh xy. That's the answer. Question number 9. Evaluate the following limits. Limit of cubed root of x minus 1 over x minus 1 as x approach to 1. If we evaluate each numerator and denominator separately, we will have cubed root of 1 minus 1, 0. This is 0. Here again, 0. So 0 over 0, indeterminate. So let's apply L'Hopital's rule here. So limit of the derivative of the numerator, that's the derivative of x to the power of cubed root 1 over 3 derivative. The derivative of 1 is 0 over the derivative of denominator is 1 as x approach to 1 is equal to limit of, look, 1 over 3 x to the power of 1 over 3 minus 1 minus 2 over 3 as x approach to 1. So x to the power of minus 2 over 3 as x approach to 1 is 1. The result is 1 over 3. The answer is 1 over 3. B, look, limit of 1 minus cos 2x over 4x squared as x approach to 0. What's cos 0? Cos 0 is 1. 1 minus 1, 0. Over the limit of 4x squared as x approach to 0, 0. Indeterminate form, 0 over 0. So the limit of this one means limit of the derivative of the numerator minus cos 2x minus 2 sine 2x over the derivative of 4x squared, 2 times 4. That's 8x as x approach to 0. Again, what's sine 0? 0. Again, this is 0 over 0 form, indeterminate form, as x approach to 0. Therefore, again, apply L'Hopital's rule. Limit derivative of sine 2x, 2 cos x, that is 4 cos 2x over the derivative of 8x, 8 as x approach to 0. Now cos 2x becomes 1. Therefore, the result is 4 over 8, that is 1 over 2. That's question number 9. Let's proceed to question number 10. Question number 10. What is the eigenvalue and corresponding eigenvector for the matrix? For matrix A, 2 minus 1, 1, 4. Matrix A, 2 minus 1, 1, 4. For this matrix, find the eigenvalues and corresponding eigenvectors. Now, we need to apply here determinant of A minus lambda I the size 2, the order of matrix A is 2 by 2 matrix I2 is 0. So this simplified to matrix A minus lambda I2, 1001, multiplied by the scalar lambda 00 lambda. Subtract from A 2 minus lambda minus 1, 1, 4 minus lambda. Its determinant is equal to 0. So 2 by 2 matrix, the determinant of the matrix 2 minus lambda, 4 minus lambda, minus 1 times minus 1 plus 1 is equal to 0. Expand here, 2 times 4, 8. 2 times minus lambda times 4, that is minus 6 lambda plus lambda square plus 1 is equal to 0. This implies lambda square minus 6 lambda plus 9 is equal to 0. That's perfect square. Lambda minus 3 square is equal to 0. From this, we got lambda 3. Then what's the corresponding eigenvectors? We know here A minus lambda I2 times x, two-dimension vector x, is equal to 0. Let x be xy. So this matrix A minus lambda I2, here we have 2 minus lambda minus 1, 1, 4 minus lambda times xy is equal to 0. This implies what's lambda? We have 3. 2 minus 3 minus 1 minus 1, 1, 4 minus 3, 1, xy is equal to 0. When multiply here, minus 1 times x, y minus x minus y, x plus y is equal to the 0 matrix, 0, 0. Now from both we will have minus x minus y is equal to 0, x plus y is equal to 0. That's the same. So y is equal to minus x, or x is equal to minus y. Therefore, what's vector x? That's xy. What's y? Minus x. So x is common factor here, 1 minus 1. So for all x element of real number, we have all corresponding eigenvectors x times 1 minus 1. That's the answer for question number 10.